Welcome, everyone, to FDO Insights 001. If you take a look at the architecture diagram behind me, detailing the Loop engine, the evaluation engine, and our routing to models like Claude, GPT, and Gemini, you'll see exactly where we're heading today. We are unpacking the Founder Development OS, and specifically, we're diving deep into the concept of the architect's edge. For the technical leaders, founders, and software engineers joining us, we know the noise in the industry right now is absolutely deafening. Every single week brings a new model and a new bold claim. But today, we're completely stripping away the hype. This presentation is an authoritative, evidence-based look into systems engineering. We aren't just here to chat about AI coding tools. We're here to talk about what actually happens to software architecture when implementation itself becomes a commodity.
So we have to start by establishing our baseline reality here. Modern AI coding tools have entirely moved past the realm of basic autocomplete. When we evaluate the data from real, professional engineering environments, the integration of these models is creating a measurable, massive surge in developer output. But from an engineering leadership perspective, this shift presents an entirely new, almost paradoxical challenge. Yes, the models are generating logic faster than ever, but writing code faster isn't the ultimate solution. In fact, without the right systems in place, it just means you're accumulating technical debt at unprecedented speeds. To understand how to actually harness this output safely, we first need to break down exactly where these models are applying leverage at the micro level.
Which brings us right into Section 1, Core Engineering Capabilities. Let's look at the pragmatic architectural breakdown of what AI actually does well right now.
When we look at the daily workflow pipeline, there are three interconnected steps where AI is objectively excelling. First up is code generation. As a practical example, modern models are incredibly effective at scaffolding the boilerplate for a new microservice. This is huge because it allows the engineer to immediately focus on the higher-level architecture rather than getting bogged down in initial setup. Second, we have bug fixing. We're seeing these tools rapidly parse really complex, multi-layered stack traces. They pinpoint the exact specific module causing the failure and suggest viable patches in seconds. And the third capability is arguably the most impactful for long-term system stability: test generation. Historically, writing comprehensive unit and integration tests is the bottleneck that teams skip when they're under pressure. But now, we're shifting from manual scripting to automated coverage. The AI can read that newly scaffolded microservice and instantly generate a robust suite of integration tests, practically securing the codebase without stalling your sprint.
But beyond just pushing new features, we have to look at system health maintenance, because every CTO knows that legacy code is the silent killer of velocity. AI's capability here is profound. We're actually using these models to safely analyze massive legacy dependency graphs and restructure them to modern architectural standards, all without breaking those delicate downstream dependencies. And right alongside refactoring, we have documentation. I think literally every engineering leader has a horror story about a critical system failure caused by undocumented context, usually left by an engineer who exited the company 3 months prior. Neglected documentation kills velocity. What AI does now is read the implementation dynamically to capture and document the actual intent behind the code. It keeps the entire team aligned in real time, effectively turning system maintenance from a dreaded chore into an automated systemic advantage.
Moving forward, let's jump into Section 2, Mastering Frameworks and Workflows. Let's examine how this fundamentally impacts the engineers themselves.
We define this strength as the capability of AI to act as an immediate accelerator for adopting totally unfamiliar technologies. It basically serves as a dynamic, contextual bridge for the human engineer. To ground this in a real technical scenario, just consider a senior engineer who needs to pivot their mental model from building standard React applications to writing high-performance WebAssembly using Rust. Traditionally, that transition takes weeks of fighting the compiler and reading dry, static documentation. Now, the AI acts as an interactive compiler for the human brain. It contextualizes the strict memory safety rules of Rust against the engineer's existing JavaScript knowledge, mapping the brand new syntax directly to their established mental models. You get a completely personalized, on-demand transition path. It's a real game changer for team agility.
All right, let's pull all these pieces together in Section 3, the Developer Productivity Multiplier.
This brings us to the absolute crux of this presentation, the architect's edge. We've talked about how AI is a massive productivity multiplier. We know it can scaffold, test, document, and fix. But here is the critical distinction we must make today. And if you take away one thing, make it this. AI writing code does not solve the hardest problems in software development. Generating 1 million lines of code rapidly just creates 1 million lines of unmanaged liability if you don't have a system to control it.
AI is an exceptional implementer, but it cannot orchestrate complex system architecture. It cannot govern business logic context, and it certainly can't manage deep engineering knowledge across a distributed team. This is exactly why engineering systems matter more than ever, and it is precisely why we are building the Founder Development OS. FDO is not just another coding assistant, it is an engineering operating system. While the AI models focus strictly on the implementation layer, FDO acts as the orchestrator. It manages the engineering knowledge graph, it enforces architectural governance, it runs the validation loops, and it maintains context across the entire software lifecycle. That is the true architect's edge, having an OS that manages the complex system so you can fully leverage the AI to actually build the product.
As we look at the reality of this entire paradigm shift, the question we want to leave you with is this. How are you leveraging the edge? Are you simply using AI to type faster, or are you utilizing an operating system to orchestrate your entire engineering ecosystem? As the landscape of software engineering evolves, the major divide won't be between those who use AI and those who don't. No, it will be between those who use AI as a standalone tool and those who embed it within a robust engineering system. Thank you so much for joining us for this technical session on FDO Insights. We highly encourage you to reflect on your own infrastructure, and we invite you to follow the journey as we continue to build out the Founder Development OS. Keep building, and we'll see you at the next session.